Okay, so pretty much in this session, we're going to talk about AWS and different products of AWS and everything. Okay, so before we go into the details of AWS, I want to give like a high level picture. What is AWS? What are the other competing products you have out there and all that? Okay, so uh, almost like 6, 7, or maybe 8 years around, there is a big move around to cloud platform. Okay, so what it means is, if you look at a company, any software company or any technology product, what you have is a server. There is an application server. There is a database server, and they're all sitting in some data center somewhere. Okay, so every company needs to have like a data center, and they have to maintain all these racks of servers. So if you I have to show you some pictures. So uh, if you see something like this, right? So they have racks and racks. Hopefully, you guys can see the image. Okay, so you have like racks and racks of servers, and they're all connected through like a high-speed bandwidth cables and everything. Okay, so when we connect to one of the server from your local machine, it will go to one of these servers. It can be an application server like a REST server or anything, or it can be a database server where you have data sitting there and you're doing a select statement or anything. So remember in the previous sessions, we were doing PostgreSQL, and we were running the PostgreSQL on our local database. But it's also possible that you can run the PostgreSQL somewhere else within the company itself, and you can connect to that database. You can get the data and all that. Okay, so if you look at maybe a website called ebay.com, so eBay has a lot of customers, eBay has a lot of products, there's a lot of feedback, there's a lot of other information and everything, so all that has to be stored somewhere. Okay, so eBay has something like these servers sitting behind some data center somewhere. It can be in Ohio, it can be in New York, New Jersey area, or California, wherever they are located. But they're all connected through high-speed cables. And all these machines here that you see have multiple hard disks inside. Okay, so in your local laptop, you only have one hard disk, and if it crashes, you cannot access the data. But if the same hard disk crashes on a server, that's pretty bad, because you're going to lose the data, you're going to lose the transaction data and everything. So they have multiple hard disks inside each of those servers, and if one of them fails, it's replicated on another disk, so they can access the other disk and everything. So yeah, so that is how they maintain this. And you have a dedicated person or a group of people who are just maintaining these machines. They take care of the power consumptions. Somebody has to take care of how much power is there. Somebody has to take care of the heat. There's so much heat that comes out of it, so somebody has to take care of the air conditioning. And maybe the hard disk might crash, so somebody has to go there, open the screw, take out the hard disk, put another hard disk, and all that. Okay, so there's a lot of maintenance work that goes there. That's what all the job of data center people that are sitting there and so on. And there's other teams like planning, capacity planning. Maybe next year they might release a new product. Maybe they need 10 more servers. Who knows? So there's a planning and all that. So it's a big team, data center team that goes there. But yeah, so what happened around 8 years back is that AWS or Amazon came up with this wonderful idea that instead of companies having their own data centers, they said, we're going to provide the data center, or we're going to provide the resources, and you guys can pay us on the pay per use, something like a prepaid telephone kind of stuff. Okay, so you call, you make a phone call, and you would pretty much um, pay only for the usage. Okay, so if you don't use the phone, that's fine. You're not going to get charged or anything. Okay, but if you use it, then you have to pay for that amount of consumption and so on. So Amazon came up with Amazon Web Services, because it's on a web somewhere else, and you are accessing those resources from the web. Okay, so that's called a cloud compute or cloud. I would say resources, because they are not sitting in the company, but they are sitting in a different location somewhere, but still it's accessible in the sense you use internet to connect to that particular platform. and then you get the data and everything. Okay. Now what happened is with that cloud platform, the companies looked at the maintenance. That means they have to rent this data center. They have to pay for the power consumption. They have to take care of this maintenance work. In the sense, as I mentioned, hard disk might fail. Somebody has to replace that. Or there might be, in some cases, like flooding, right? In some cases, it might even flood the data center. If you have like a Hurricane Sandy or any of those, they have to take care of all those things. So companies look at cost analysis. They see how much am I spending per year here, and how much am I going to spend with AWS platform. And you can also imagine every 5 years, the servers have to be replaced. In the sense, if you look at your laptop or computer, every 5 years you might have to. It's pretty much that something is going to fail, and the new CPUs, new processing power is going to be much faster with less power consumption. So every 5 years, it's pretty much that you're going to trash whatever the server there is, and you're going to buy something new and everything. Okay. So companies look at all this information and they say, okay, it might be cheaper to use AWS. It's a pay per usage. Okay. So companies don't take care of the maintenance work. Amazon takes care of the maintenance work. Okay. So if some hard disk crashes, it's the job of Amazon to replace that hard disk. They don't, we don't even know whether something crashed because they have replication mechanisms. We still have access to the data. They, from their point of view, they guarantee that it's going to be 99.99% guaranteed, unless there is like a September 11 kind of a terrorist attack where the whole Twin Tower got bombed and all that. So pretty much that, unless those kind of scenarios, they guarantee that 99.99% of the times, these are guaranteed to be working. So the companies look at cost analysis and they use AWS. Okay, so after AWS, Microsoft started it. Microsoft has Azure platform, and then Google also has Google Cloud Platform, GCP. Now there are competing products. We're going to look at the details. What are the differences and all that. And we're also going to have a small demo connecting to this. We're gonna probably have a service running on this AWS platform. And then let's try to interact with AWS, right? Okay, so hopefully you guys created that AWS account. But yeah, so we have different products. We have AWS, okay, Azure, and Google Cloud Platform, okay? So AWS is one of the products, okay? So you have Amazon Web Services, okay, Cloud Services. And then you have Microsoft's Azure, okay? So Microsoft Azure took a little different approach. And if you look at GCP, Google Cloud Platform, sorry, can you see my screen actually? Yeah, I think you can. Okay. So yeah, Google Cloud Platform, they actually took a completely different approach. Okay, so we're going to talk about some of the differences. Yeah, first let's start with AWS. Okay, so this is GCP, Google Cloud Platform, what you're looking at. They have something similar, but they're also like something very drastic that is different from AWS versus Google Cloud. There are some advantages and disadvantages, but yeah, let's go through each one of them. Okay, so as you can imagine, so let's say you're trying to develop some software. Okay, so what do you have? You have a server that is running. That means you send a request, somebody has to send back a response. Okay, so we looked at last time. There's a Django, Flask, different kind of servers, right? So for that, AWS has something called API Gateway. Okay, so if I go to my AWS account, okay, oh, before even going there, yeah. So once you log into AWS, this is what you're going to see. Okay, and for the people who are on the testing side, this may not be that important because you will be testing the application. You won't be modifying the services. Okay. So this is maybe something it's good to know, but it's not something that is required. Yeah, I would say for you guys, maybe it's good to know, but for the who are on the development side, who are actually developers, this may be more something more for you guys. Okay. But yeah, so once you log into AWS, this is the management console that you're going to see. Okay, so here you have a different type of information, but on the top left you see services button there. So when you click on the services, this shows up all the services that are provided by AWS, and there are many services. Okay, so as you can see, I can even yeah, it's more than a page of services. Okay, so there are some primary services that we're going to look at today. So first, so whenever you want to expose something on the web, like a server, where you send a request, you get back a response. So there is something called as API gateway. Okay, so I'm going to do search for it. API. Okay, here it is. So it's under networking and content delivery. There is something called as API gateway. Hopefully you guys can see it. I'm going to zoom in a little bit. Okay. So here is API gateway, and what that means is that I'm going to have an API endpoint on that gateway. Okay, so yeah, before I dig into details, let's look at a high level. Okay, so I have clients who are connecting to my server and getting the data back. Okay, for that I can use something like API gateway, which exposes different kind of endpoints. Okay, and then there is a data, there has to be a database where the data is sitting and all that. Okay, for that they have something called as relational data store. Okay, let me search for Audios. Okay, there it is, databases. Okay, so you can see there are different type of databases. RDS is the typical relational data store. You can have MySQL, PostgreSQL, Oracle, Microsoft SQL Server, anything you want. You go to RDS, you specify what is the database you want, and it will create a database for you on the cloud. Okay, so you have to wait for like 5 minutes or something, and then it will create a database server, and then it will give you the environment so that you can create tables, you can insert data and all that. Okay. So there are different type of databases, as we saw last time. There's a Mongo database, there is Cassandra database, there is cache databases, and so on. So this provides Amazon provides all of these kind of different databases. So that are for different use cases. Okay. So I want to give you a high level, and then I'm going to go into low level details later. Okay. So AWS provides a database. So if let's say if I want to store some data, I will go to AWS platform. I will create a database, and then I can create some tables, and then I can store my data. Now all this is in the cloud. Cloud in the sense in the internet somewhere. I don't have to store it, or I don't need to have a data center. Okay. And I have to pay how much data I'm storing. So if it is like a small data store, maybe I pay $10 a month. But if it's like a huge data, maybe I'm consuming 1 terabyte, 2 terabytes of data, and there are so many requests that are going to the database and all that, maybe I have to pay like $1,000 a month. But that is still cheaper compared to hosting those servers internally inside the data center for some companies. Okay, so for some use cases, this might be cheaper. Okay, and then let's say in a typical application, you have a file system. Okay, you have storage. Storage means you have some files. You are storing the files like a hard disk. Okay, for that you have different storage systems provided by AWS. You have S3. You have Elastic File Storage and all that. So we're going to talk about the details later. What are the differences between those different storage? But S3 is pretty much it's a network file storage. Okay, network file storage means usually a storage is inside a machine. Okay, that means if my machine crashes, the hard disk is unreachable and all that. Okay, but S3 is outside the machine in the sense S3 is something. Think of it like a network. Okay, network file. I have a hard disk, just a hard disk that I can connect, pull some data, and so on. Okay, I don't have another machine connected to it. Somehow you can think of S3 as a file server. You can put some files, you can get some files, create some directories, and all that stuff. Okay? You don't need to have a machine associated, but S3 is pretty much a storage. Okay, Think of it like a hard disk, standalone hard disk. Okay. There is elastic file storage also. We're going to look at those things. But yeah, so you have storage, you have database, you have API gateway exposing different endpoints. But let's say I don't want a storage, I don't want an application server or a database, but I want a proper machine. That means I'm going to deploy some software, my own software. I don't care about databases. I don't care about, or maybe I care about it, but I want the whole machine for itself. That means the whole server, the CPU, the anything that comes with it. Okay. So in those cases, you have something called as EC2, Elastic Compute. Let me just, there you go. Compute. Okay, EC2, Elastic Compute. That's pretty much is like a. If you go to EC2 Elastic Compute and say, "Hey, I want a machine," you can get the whole machine for yourself. But that's going to be expensive compared to other products. But yeah, you can get the whole machine. You can deploy your own software. Yeah, so that you can even get multiple machines and all that. So that is Elastic Compute. And you have different options. You have like a shared machine, you have a dedicated machine for yourself. Dedicated means the whole machine is allocated for you. A shared machine means what they do is they call something as, I would say, virtual machines. That means, let's say you have a server that has a really nice CPU. As we saw last time, CPU has 32 cores, 64 core machines, and everything. So you may not need all the 32 cores or 64 cores. You may need 2 cores or 3 cores or 4 cores or so on. So when you create a machine, you can say I need only 2 cores, 1 core, and so on. So what the AWS platform does is AWS platform is going to create those resources, and it's going to give you the resource IP addresses and all that. And then you can pretty much deploy your own software and all those things. Okay. So there's also something called EC2 Image Builder, which is pretty much as you can imagine. You can create your software images. You can use it to configure what kind of software you want to deploy and all that. There is also AMI, Amazon Machine Image. Okay. I think, yeah, Image Builder is AMI. But that's fine. Okay. So yeah, so now you can see the different flavors of the services. You have databases, you have storage systems, you have the whole machine for yourself. Let's say you don't want the whole machine for yourself, but you want maybe to process something with your own software, but you don't want the whole machine for yourself. Okay. So in those cases, you can use a Lambda. Lambda pretty much means you are deploying your code, but you don't want the whole machine for yourself. You're just saying, I want a small piece of software that should be executed when something happens. That something can be like somebody is making a request to the data, then you want to execute some piece of code, send back some response. So that is AWS Lambda. Okay. So we're going to look at all these AWS Lambda functions, all these different methods and everything. Okay. So for now, I'm going to click on RDS, which is the database, okay, relational data store, okay. And I just want to show you nothing happens. All right. So I clicked on a relational data store, okay. So what you see here is still from the UI, okay. So I have console. This is called dashboard. Dashboard means you click a bunch of buttons, you can create a database, you can get a machine, you can get a storage system and all that, okay. There's also another way you can create this. You can automate using some programs, Python programs, using some libraries called Boto3 library. There is also a Terraform template. You can also declare everything in a file that's called templates, Terraform templates, and you can use them to create also. But yeah, so let's work with the console first, management console, and then we're gonna look at the other things, which are what is a Boto3 library, what is a Terraform template, and all that. Okay. So once you're familiar with the console, once you understand what are the different products, then it will make it easy for you to understand the other stuff. Okay. So I clicked on relational data store. Now you can see on the top it says create database. Okay. So I'm going to click on create database. Okay. So now it gives me a bunch of options, what kind of database you want. And there are other username, password kind of setup and so on. Okay. So as you can see, forget about this Aurora. I'm going to come back and talk about this. But you can see there's a MySQL, there's MariaDB, PostgreSQL, Oracle, Microsoft SQL Server. Okay. So I can select any one of these and I can create a database. Okay. So you guys are familiar with PostgreSQL. So in the previous session, we installed PostgreSQL on our local machine, and we actually created some tables, data, and all that. Okay. But let's say you don't want to create locally, you want to create on AWS, you can select that option, which is PostgreSQL, and then you can specify some additional data, which is like what version of PostgreSQL do you want? Do you want like version 10, 11, 12, all that? Okay. So depending on the use case, you can select what version of PostgreSQL you want. And if I scroll down, you can see there are some credentials. So you can specify what is the master username password. So this is the administrator password. So using this administrator password, you can create other users. You can create tables, schema changes, all that kind of stuff. Okay. But this is a administrator password, username password that you're creating here. Okay. And then, yeah, so storage. How much storage do you want? 100 gigabytes. In the sense that's the story. I mean, you can always change it later. Once you reach 100 gigs, you can change it to more, but the minimum is 100 gigs as of now. And you're going to see another one most of the times, which is IOPS, input output operations. Okay, which pretty much means how much CPU are you going to consume. Okay, that means 3000 input output operations per second. Okay, PS stands for per second, which pretty much means if you say a very low number, they're going to have one machine. Okay, but if you put a very high number, they might have 10 machines. So when the request comes in, it goes to one of those 10 machines, and then your request will be much faster. Okay, and depending on the load, they may create behind the scenes those many number of instances. They will take care of the load and all that, but they want to get an estimate of what is the use case that you are using, so that they can allocate a proper horsepower, you can put it in that way, okay? Proper computing power, so that they can compute very fast. Okay, so they want to get an estimate, and that's where input output operations per second comes into picture. Okay, but yeah, okay. So there's also VPC, which is virtual private cloud. Okay, so if you don't want the database to be exposed on the internet, but you want only the database within that company IP address and so on, it doesn't make sense for the database to be exposed to the internet. Only your applications are connecting to database and inserting the data, retrieving the data, and all that. So in those kind of cases, you might want to make it a virtual private cloud. That means it's not exposed on the internet, but it's something that you locally or your application is going to connect. Nobody else from the internet is going to connect and all that. Okay. So there are different options. You can select them. And finally, at the bottom, if you click on the create database, that's when this will be created. Okay. And as you can see, they give you estimated monthly cost, which is $800 per month. Okay. So with the options that I selected, so it comes to this thing, $800, $857 per month. Okay, which is not cheap actually, which is pretty expensive. But for some companies, this might be cheaper. Okay, but that's fine. So let's, Yeah, let's not look at the cost because we won't be involved. But the company has already decided that they wanna use AWS platform, and it's our job to use those services. Okay, so let's understand the services point of view. I'm not going to click on the create database because I already have a dummy database created. But yeah, so I'm going to just show you these options here. But if you click on create database, it's going to create a database. And if you're going to use those many IO operations, then it's going to be that much. But if you don't use that, then it'll be lower and everything. All right, so here I said Aurora, I'm going to come back and talk about this, right? So you will see all these are standard databases. That means MySQL is an industry standard. PostgreSQL is an industry standard. Oracle, same thing with Oracle, Microsoft SQL Server and everything, okay? This Aurora is something Amazon developed, okay? So Aurora is something that Amazon kind of cheated. Cheated means they actually took MySQL and then they modified few things here and there. They modified for cloud platform and they named it as Amazon Aurora. Okay, I mean these softwares are open source. The PostgreSQL is open source, MySQL is open source, so you can get the software, you can modify, you can use it, you can even publish as your own database and all that. So Amazon did that. So Amazon took MySQL code and they said we're going to modify a few things for the cloud platform and we're going to brand it as Aurora. Okay. Same thing they did with PostgreSQL also. They took PostgreSQL. So when I click on Amazon Aurora, it gives you two options. Okay. So you can see Amazon Aurora with MySQL compatibility. Okay. That means behind the scenes, it's actually MySQL. They kind of cheated. That means they took MySQL, they modified, and they're saying this is called Amazon Aurora. Okay. Same thing with PostgreSQL. They took PostgreSQL and they modified a few things and they called it Amazon Aurora also. Okay, so once you select Aurora, you can decide whether you want PostgreSQL or whether you want MySQL compatibility. So let's select PostgreSQL, and if I scroll down, you're gonna see the same options that we saw last time. When you select PostgreSQL, you have to select what version of PostgreSQL you want. So the thing that comes into picture is behind the scenes, it is actually PostgreSQL. Okay, so when the PostgreSQL releases a new version, Amazon Aurora has to take that software. They have to make those changes that they made for previous versions. They have to make it for the new version and all that. But yeah, Aurora is pretty much behind the scenes. It's either MySQL or either it's a PostgreSQL. And then it explicitly asks you what kind of database you want. Do you want MySQL or do you want PostgreSQL? Okay. And then once you select one of them, it will tell you what version of PostgreSQL do you want. Okay. So in this case, I'm selecting the latest version. And it gives me whether you want to store some testing kind of stuff or production. There are some subtle differences, but for now, I'm just going to say test. Okay. I'm going to select the same options as before. I'm going to look at the cost here. It doesn't say the cost. Okay. This Aurora is supposed to be a little cheaper compared to PostgreSQL, but I don't see the cost here somewhere. It has to be there. Okay, fine. Okay, they don't show those cost options, but this is something Amazon developed on its own. And they claim that since they modified for the cloud platform, they claim this is going to be faster compared to PostgreSQL. But yeah, it's up to you. If you want to use Aurora, that's fine. But behind the scenes, it's running PostgreSQL, and there are some subtle differences and all that. Okay, so that's a database. Okay, now I want to switch gears here. So let's look at other platforms. Okay, so this is a good example of what does AWS provide. Okay, so there are many services, but these are like some of the basic services. Okay, so I'm going to talk about other services a little bit later. Yeah, any questions so far before I jump to Azure or maybe Google Cloud Platform?
No, I guess it looks good.
Okay, so let's jump to Azure. Okay. Azure, I don't have a login there, but now Azure is very similar to AWS platform. Okay, so let's okay. So Azure SQL family. So Azure, as you know, is a Microsoft product. Okay, so I think Microsoft started almost like 1-2 years after AWS started, and AWS started picking up a lot of clients. Microsoft started the same service, but now there's a lot of companies that are moving to Azure than AWS. I mean, AWS captures like 60-65% of the market. Azure has another, I would say 20% or something. And then Google Cloud Platform, there is an open stack, which is from Red Hat Enterprise Linux. They all come number 2, number 3, and all that. But yeah, so this is the second heavily used platform. Okay. So here, Azure SQL. So if I click on choose your database, so you can see they're not giving you an option here. Once you select one of the options there, then they might give you one of those. So they expect you don't know much. So they're asking you a bunch of questions. And then based on that, they're going to tell you which database is good for you. Okay. All right. So as you can see, um, Microsoft has its own database. Okay. Microsoft has SQL Server, Microsoft SQL Server. Okay. And they are competing with Oracle. Okay. Oracle has its own database. Microsoft has its own database. Obviously, if Microsoft is using Oracle database, then they have to pay Oracle their competitors, but Oracle is not going to give them for free because they are competing. They don't, they want customers directly to move to Oracle and all that. So they're going to give a very high price to Microsoft. So when Microsoft says, "Hey, Oracle, I want to use your database," Oracle is going to give them very high price so that they're not even going to use it. Okay, so Microsoft uses its own database, which is the SQL Server database. Okay, behind the scenes. For AWS, you have all these options, which are different options, Postgres, or you can explicitly say, I want this, and so on. Okay. Azure, on the other hand, they're not even telling you. I mean, I'm sure behind the scenes they use Microsoft SQL Server, and it's pretty much that you don't have much choice here. Okay. Now, same thing. If I go with Google Cloud Platform, okay, GCP, Google Cloud Platform even takes a different approach, drastically different approach. Okay, so at least Microsoft's SQL Server is a database that's an industry standard database and everything. Okay, and now GCP, Google Cloud Platform, it has its own, which is a database called as Bigtable. Okay, they use this Bigtable for search engine. Google search engine runs behind. They say it runs on Bigtable. But yeah, so this is something Google developed on its own. It doesn't use Microsoft SQL Server, it doesn't use Oracle or anything. So when you go to GCP platform, there is no choice for you. You have to use this Bigtable query. Okay, they give you their own SQL syntax. So there is some minor difference between the standard SQL and this SQL. But you don't have a choice. They say the performance is really better. Sometimes they claim that this is like almost like 10 times faster than PostgreSQL and all that. They don't even give you access to the database. They say just here is SQL. This is how you create tables. This is how you would access the data and all that. But behind the scenes, they are running their own version of software. They can change the version. I mean, today it might be 10.0, tomorrow it might be 11.0. You don't even know that something got changed. They have the full control on that database. At least AWS platform is telling you that, hey, if you want to use PostgreSQL, you can select what version of PostgreSQL you want. And on the Bigtable, There's no such choice. I mean, they take care of the database is owned by them. So there's nothing for you to actually choose when you want to upgrade, when you want to downgrade, or anything like that. You don't even know that something got updated. Okay, so this is a completely drastically different option from the other two things. Now, if you look at the advantages and disadvantages, right? The advantage is that this performance is going to be much faster. Bigtable, it's going to be, as they claim that, I mean, there are other industry research also. They compare different databases and they say that Bigtable is faster, which is a very good advantage. And the price wise, I think it pretty much matches with other things. But if you, let's say you create some tables here, let's say you store some tables here, and let's say tomorrow you don't want to use Google Cloud Platform. You want to move it to in-house, maybe your own data center, or maybe you want to move to AWS platform. You cannot move it because you're stuck with that big table, right? Now you have your own tables. There is no easy way to migrate away from the GCP, right? Because you cannot, I mean, let's say if it's a PostgreSQL, I have a PostgreSQL in data center. I can create the same Postgre on AWS platform, and then I can simply migrate the files, and everything will work fine. Okay. But if I use something like a big table and it creates a bunch of tables here, migration is going to become a pain. That means I have to write my custom code or some connectors that can transform from one format to another format and all that. So that's one of the disadvantage. That's like if you once you start using GCP, you are stuck with GCP. Okay. So that's one of the drawback of GCP. But yeah, I mean, some companies use GCP because they really care about performance. But you can be kind of like, it's like a California hotel, right? They say you can check in, but you cannot check out. Something like that. You can, okay. Once you start using it, it may be difficult for you to move away from that GCP platform. Okay. But anyways, so that's how I would compare and contrast. Everybody has their own advantages and disadvantages. Okay. Now let's look at some of the other products. Now on the GCP platform also, okay, so let's look at some of the other projects here. They have very minimal products compared to AWS platform, but they have some really nice products. Okay, they have some very good machine learning products. GCP has certain machine learning models which are really good. So Google, as you know, develops its own software. So there are some advantages or some products that are really good. That means, let's say if you go with AWS platform, you have to develop your own software. They are providing the hardware in the sense they provide the hardware, you put your software, and you maintain the data, you maintain the software and everything. Okay, that means they are providing the infrastructure on the cloud. Okay, just I would say, yeah, the hardware resources and all that on the cloud. Okay. Now, if you look at Google Cloud Platform, they call it platform as a service. That means they provide the data, they provide, sorry, not the data, they provide the platform, the whole platform. In the sense, let's say you have some machine learning models, or let's say you want to have, yeah, let's go with machine learning models. Okay. So let's say you want to have your own search engine. Okay. If you want to use AWS, you have to write some search engine code, all that. Okay. But using GCP, they will provide the software also. Since you have the software, you're just using that software. Okay, so this is called platform as a service. That means you get the software, you get the hardware, you're just using their software. Okay, so that is a different paradigm compared to AWS, because AWS is providing the hardware, and GCP is providing you the hardware and the software on top of it. Okay. But AWS also picked up some of those things. And if you go to Kinesis, AWS Kinesis and all this, so you can see there's a lot of machine learning models here. So AWS also developed its own software. So if you use any one of these software here, AWS machine learning of these, it's pretty much that you're using AWS software, and behind the scenes, you're also using AWS hardware. But yeah, so this also has some of the components, and I think they brought it up after GCP came into picture. But yeah, so there are different products, but yeah, there are some advantages and disadvantages of using different platforms. Okay, so now you can also have mix and match. That means, let's say you have a database on AWS platform, but you can have an application server running in-house. Okay, so think of this way, right? So if everything is in the same data center, you have the server there. Let's say you're writing a Python program. Okay, the Python program is connecting to database, and it's pulling some data, storing some data, and all that. Okay, same thing. You have the database instead of running locally or instead of running in a data center. Now it's running on AWS platform, but your Python code is running in the company or on your machine, and you're connecting to AWS platform for the database part. Okay, so you can connect for database part. You can pull the data. So your Python is running locally, and your database is running on AWS platform. So you can mix and match also. Okay, um, so since you're connecting to AWS platform, there are some permissions. Who can connect to AWS platform? What can they do? Can they delete the data? Can they create the data and all that? Okay? So all those permissions goes into a product called as IAM. Okay, so if I look at IAM. Okay, there you go. Security, identity, and compliance. Okay, so IAM pretty much means it's identity and access management. Okay, so if I open that console, IAM console. Okay. So here you on the left side, you're gonna see something called as user groups. Okay, um, and you're also gonna see users, roles, policies, and all that. Okay. So as the name says, user groups, right? That means pretty much you have a bunch of users and you're creating a group of those users. Okay. So let's say you have a team of 10 developers. Okay. So you are part of the development team, but there are other 9 people in the development team. You can create a group for your own team, and that group has 10 developers. Okay. Now, each person in the group has the same permissions. Okay. That means if you can delete the data, your team member should be able to delete the data. So all of them have the same permissions. So you create a group, a user group, and then you set the permissions on the group. That means, can the whole group read the data? Can the whole group write the data, delete the data? All those permissions, you set it at the group level, and the group has a bunch of users inside. Okay, so that's user groups. Okay, you can create a new user group if you want to. Okay, so yeah, there's an option to create. Multi-factor authentication is separate. So let me create some users first. Okay, so user group is a group of users. Okay, now there's another option which is users. Okay, so you can also create individual users. Okay, so when I say individual user, it can be a real user or it can be a fake user. Okay, a real user is someone like you who is a real user, who is going to log in, who is going to take care of doing certain things and so on. Okay, a fake user or a user, there's no real user behind the scenes, but we use that user ID to run certain things. Okay, so if I run it under my name and tomorrow I leave the company, that means that user ID is not going to work. So you don't run your process under a given user, uh, under a real user. You always run a user under a process under a fake user. Okay. So you create a user that is like an automated user or something, and and then you run your process under that user. Okay. So, but yeah, before we go into different kind of users, so let's say you want to create a user. Okay. So you can click on this add users on the right side, top right, and then it takes me to a web page. It says pretty much similar to username. So you can see whether you want programmatic access. That means you can use APIs, libraries uh, to connect to these services, or console access. Okay, that means can you open up a web page and can you see what is the console access and all that? Okay. So when you create a user, you can set all the permissions for this. I mean, there are multiple pages, 2, 3, 4, 5, 5. So what are the permissions, tags, and all that? So let me just create a demo user here. Okay. I want the programmatic access. I want the management console. Let's create a custom user. I'm going to create with a dummy password, welcome 123 or whatever. Okay. So next I'm going to go to permissions. Okay. Now here it says, do you want to create a group? Okay. Since I have a user and that user, now I can create a group for this user. Okay. Because in the future, if I create more users under the same category, I can add them to the group and then everybody gets the same permissions. Okay. So for now, I'm not going to create a group. I'm just creating an individual user. Okay. So as you can see, you can also copy from an existing user. So if another person is there and you want to have the same permissions as the other user, you can copy. But these options are not something recommended options. You always want to create a user group and you want to add a user to the user group so they get all the same permissions and all that. Okay. So I'm going to go with the add user group. Or yeah, let me create a group actually. So create group. I'm going to say, so I'm going to create all these resources, but after this session, I'm going to delete this because I may get billed and all that. So for now, I'm creating all these different things. So here I'm going to say administrator access for now. Okay. Fine. So API gateway administrator access also. So I'm going to select a few policies here and there. We haven't talked about policies, but let's say I selected a few policies there. And then you can add some tags, like let's say you have many users, many groups, and all that. Okay, so searching becomes difficult. Okay, so you can add some tags here. You can say like class group or whatever. Okay, so I can create different kind of tags there. But yeah, so that is how you would create a user. Okay, so I just created that user there, and you have a demo user and everything. Okay, so now using this user, I can run some processes. Okay, so this automated user, now I can use it to run certain processes and all that. Okay, so I have a user, I have a user group. Now let me show you some policies here. Yeah, before I go into policies, there is something called as roles. Okay, the role pretty much says what can the user access. Okay, is the user does the user have access to API gateway? Does the user have access to the relational data store? Yeah, different kind of roles that you have. But yeah, so you can select the different roles, and then you have some policies. That means here the role is pretty much what kind of user is he? Do you want to run the service under this user or that user? But yeah, you have different roles there, and then you have policy. Policy is important. That specifies whether you can have read access, write access, what kind of permissions you have. So you can see there's a Glacier read-only access. Okay, so there is RDS full access. That means this person can delete the data, modify the data, or so on. Okay, there is a EC2 full access. So I can select a bunch of a bunch of these policies or one of those policies, and I can also expand this, and I can. I don't think I can modify this. Okay. Yeah, fine. But you can also create your custom policies. If you don't want all of these permissions, you can remove some of these permissions here. But yeah, so so you can select what kind of policy you want for this user. Okay, so let's say you want to read permissions, you can enable the read permissions, write permissions, or all those policies. Okay, so that's where the permissions come into picture. I mean, for a small team, that might be okay, but for a big team, let's say there's eBay, like a company, there are 10,000 employees. out of the 10,000 software developers, everybody is using their own cloud platform. So you definitely want to have a group. Your group is going to have different permissions from the group that owns a different product. Okay, so in eBay there might be a search functionality. In eBay there might be a feedback team. In eBay there might be some other team that takes care of promotions like advertisements and all that. Okay, so different groups have different permissions. So you create a user group. You enable certain policies, permissions for that. Another user group may have different permissions. But yeah, so all those things you can do with this identity and access management. Okay, so who can access what? That is what identity and access management is. Okay, that's called IAM. IAM pretty much is one of the products, and it's a required product in the sense any service that you use, you need to have the permissions to access those things, and the permissions come from this product IAM. Okay, and unlike other data, like let's say you are using a database and you have some data tables and everything, you might be billed based on the usage. Okay, that means if you use more, you will be billed more. But here, IAM, identity and access management, this is not something you pay per use. Okay, this is something you can change the permissions, you can set the permissions, but there is no, I mean, there's no charge as such in the sense this is running behind the scenes. When somebody is trying to access some things, it will try to check here, but this is not something they charge anything over there kind of stuff. But yeah, this policy is something that you can use to limit the access, so you know exactly who is doing what. Okay, all right. So that is IAM role. Okay, now let's look at something called Lambda. Okay, so let's look at API gateway, right? So we were talking about creating a sample service and everything. Okay, so let's search for API gateway. Okay, here it's API gateway, network and content delivery. Okay, so before I jump into some details here, any questions so far?
Yeah, so I just had a thought like, okay, supposedly I have my current database on my on-premise office data center. But now I want to move to the cloud database, supposedly to the AWS or GCP or Azure.
Yep.
So what are the things that I should first consider? Like what things I have to work on before I move in there? Because there should be some stuff that is related to the CI of it, like CI/CD pipeline of it. So what things I should consider?
Yeah, so one thing is how much effort do you want to spend, right? So let's say you have PostgreSQL database. You don't want to change. You are happy with PostgreSQL, but you just want to move it to the cloud. So you would go to AWS, you would select PostgreSQL, and every database has an export option, has an import option. Okay, similar to Excel or any other software, right? So you can export the data into files. Okay, once you export it, you have an import option. You can import the same data into AWS platform. Since it's the same database, same version, you don't have to worry about changing the data format and all that. So if you're moving from apples to apples, you are happy. That means you're not spending extra effort. AWS has a connector that can pretty much pull the data. It will take care of internally exporting the data, importing into AWS and all that. But let's say if you want to change the format, that means you are PostgreSQL, now you want to move to Oracle, or PostgreSQL or MySQL, and you want to move to PostgreSQL and everything to the cloud platform, or maybe a big table. Okay, so you have software or data in one database, and you want to move to a different database. Okay, then you have to write your custom code. That means you have to write something that can take the data from one format and change into a different format and insert into the destination database. Okay, for that, there are in AWS there is S3 buckets. S3 is where you would store storage and everything. Okay, as we discussed. That means S3 stands for Simple Storage System or something like that. Okay, S3, 3S, Simple Storage System. Okay, So you transfer all the data to S3 location, and from S3, now it's your job how to load data into the database, destination database. Okay. Now you can write your custom code. You can use a Lambda function. So Lambda is one of the things that I'm going to talk about now, which has your custom code that can read the data. It knows what is the source, it knows what is the destination, and then it can pretty much change the format and insert into the destination database. Okay? So it depends on how much effort you want to spend, and it may be a 6-month project or it may be a 2-week project. Okay, if it's a 2-week project, you definitely don't want to write your custom code because that will be a long effort. But if it's a 2-week thing, you just say, I'm going to move from Postgres to Postgres, and I just copy, export, import, that kind of an option. That is what you would do. Okay. But yeah, this is something, a few things to consider. But coming to Jenkins, I would say CI/CD may not come into picture in this migration of a database because CI/CD is mostly for writing the software and then integrating them in the sense, how am I going to bring it to the cloud platform? Let's say you're writing your own custom software, then you have to worry about CI/CD. Then in that case, you are pretty much have to test your software, package that software. All that comes under the Jenkins. But the job, the job of migration is not going to be Jenkins' job. It's something that is running on AWS platform or somewhere else, and pushing the data to destination database.
Oh, okay. So supposedly, if we want to transfer the data from Jenkins, which is open source, to the GitLab, so in that case, I have to take care of the CI/CD packages that I'm using. But in this case, I might not need to deal with this all stuff.
Yeah, that's right. So yeah, that's correct. Here you may not even for migration, you may not Jenkins may not come into picture. I mean, unless you're writing a code, it may come into picture for only testing that code and packaging that. But yeah, other than that, it may not come.
Yeah, cool. Thanks.
Yeah, sure. Yeah, any other questions? I mean, I'm going to talk about API Gateway Lambda with a demo, simple example here. But any questions before we jump in there? Okay, all right. If no questions, then let's create this. Okay, so API Gateway. So again, for people who are on the testing side, don't worry about this. This is going into details. You may not care about this, but it's good to know. Okay, so what is the API Gateway? API Gateway means what is an API in a sense? API means access point or access application programming interface. Okay, that pretty much means that there's an interface. That's how you talk with the server. Okay. Interface in the sense there's a user interface where you're interacting with the product by clicking some buttons and all that. So that is user interface. Okay. So this is programming interface, which is application interface and so on. Okay. That means one application is talking to another application. And that is what API stands for. Okay. Now what's a gateway? Gateway means this is where you are exposing what is the interface, what does it accept, and all those things. Okay, so let's say I'm going to create a new API endpoint. Okay, so I created this product info before the class just to verify I have the permissions and everything. Okay, so on the right side, I'm going to create press this button called Create API. Okay, and it gives me different options. Okay, HTTP, WebSocket, REST APIs, and everything. Okay. So I'm going to click on REST API, but I see two REST APIs. Okay, so one is accessible within the VPC. Okay, that means that's not a public. From the internet, you cannot access it. You need to be part of the network. Then only you are able to access it. Okay, VPC means virtual private cloud. So I'm going to talk about VPC a little later. But VPC pretty much means within the company itself. Okay, people from outside cannot connect. It's not exposed to the internet. Okay, so let's assume that. Okay? And then you have this one, which is a public API. So I'm going to create a public API. Okay, I'm going to say build. Okay, now it gives me all these options. Okay, it's a new API. Okay, I'm going to take from example API. Okay, one of the example APIs, and actually let me go here one more time. Actually, you know, there's another way, easy way to create an endpoint. Okay, so let me not do this way. So this is API gateway. We expose different endpoints here. Okay, but there's a shortcut of how to create this gateway interface. I'm going to go to Lambda first. Okay, so I click on the Lambda. Okay. So now I'm on the AWS Lambda page. What is a Lambda? Okay, so a Lambda means you can write some piece of code, some software, and that will execute it. Okay, I mean, there's one way you can get the whole machine for yourself, which is EC2, Elastic Compute. That means you're getting a whole machine for yourself and you're paying a very high billing for that. But instead, you can have a small piece of software that can execute for maybe 5 seconds or 1 second, and you're not going to use any machine resources. Okay, so that is Lambda. Lambda means it's going to run for a very short period of time and it's going to exit. Okay, so that for all those use cases, we use Lambda. Okay, so I'm going to create a Lambda. That means I'm going to use the resources for a very short period of time, and then I'm going to not going to use those resources. Okay, so here that is pretty much what Lambda means. So I'm going to say functions, and I'm going to on the right side I'm going to say create function. Okay, create Lambda pretty much. Okay, and then it gives me a bunch of options. Okay, are you going to write your own software? Yes. Or you can use a Lambda blueprint, which is pretty much similar to like a Django Flask kind of application. Okay, or you have like a sample code that you're taking that you're changing some data here and there kind of stuff. Okay, and then you have container image. Image pretty much means, um, yeah, I haven't talked about Docker images and all that, but pretty much it's a package. Think of it like a package, the package that's already built for you beforehand, and you're going to run that package inside the Lambda. Okay, so that is another option. We also have a serverless repository. We don't care about that for now. But yeah, so let's select this author from scratch. Okay, that means I'm going to write my own software. Okay? And then I'm going to select this function name as, let's say, customer info. Okay, so you have let's say you are ebay.com. Okay, you're a website. eBay has a login. That means when you log in, you have the account information and so on. Okay, so when somebody clicks show me the profile information, we display their email address, phone number, physical address, and all that. Okay, so that needs to be an endpoint so that when they click on that, we display all this information. Right, so I'm going to create a endpoint for that, which is pretty much user info. Okay, so give me the user info for this particular user. Okay, so I created user info, and here the languages, I can select different kind of languages. What kind of language do I want? All that. Okay, so here I'm going to select Python 3.7 for now, or I can select the latest Python 3.9 also. Okay, so let's go with Python 3.9. Okay, the latest one. Okay, and let's look at advanced settings. Nothing there. That's fine. Okay. Okay. So now look at the permissions, right? So it's saying what kind of permissions does this Lambda want? That means when I'm running the software, I may have to access a database. Okay, to access the database, I need to have permissions to access the database. Okay, so it's pretty much asking me what kind of role do you want? That means you want to run this function software under some user. Now that user needs to have permission. I'm going to select a use an existing role. I think I created a demo user, or I'm going to use this product info role. Okay, so I'm going to create use an existing role. Okay, um, I'm going to develop from scratch. And the API endpoint is going to be user info. Okay. And then I'm going to create this function. All right, here we go. Okay. So I have a user info, and then, but this is just a Lambda here. Okay. So you can see that it has a sample code there. So this, let me zoom in a little bit. Okay. As you can see, there's a handler in there. That is a function that will be called anytime this Lambda is called. Okay. That function has an event. That event is pretty much, it can be a request, it can be anything else. They call it an event. Okay. And there's a context. Context means some information about the request, like what environment. Is this a development environment? Is it a production environment? Some other, there is also something else called, I believe, some tracking number, tracking ID kind of stuff. So all that tracking ID goes into context. But the request itself, that means, let's say I send a request for user info of rich@gmail.com. Okay, so I'm saying, give me the information for rich@gmail.com. So all that the request information is sitting inside the event. Okay, so here there is a simple function that is returning a JSON data, and the JSON data is returning 200 status code and a body which says hello from Lambda. Okay, so I'm going to remove this and say hello from Miracle Solutions. Okay, so let's say I just call this hello from Miracle Solutions. And I can test it. Okay, yeah, let's test it for a second. Okay, and then I'm going to say test Lambda. Okay, so this is the request. What kind of request we want? Here I'm not even looking at the event. Any event that I get, I'm just saying hello from Miracle Solutions. Okay, so it doesn't matter what request I'm going to send. So I'm going to leave it for now here. I'm going to create that. Okay, so I'm going to say test Lambda. Fine, don't worry about that. So I'm going to press deploy. Okay, so when I deploy this, this is going to connect to API gateway. By the way, did I specify the API gateway somewhere? Okay, I think I have to specify. Yeah, here add trigger. Okay, so that deploy, I think, yeah, it actually released. So it's pretty much like save this code. So since I made some changes, deploy pretty much means like save it. Next time you run it, execute this new code. Okay. Now I'm going to add a trigger here. Trigger means how does this Lambda get executed? Okay. And here I'm going to select API gateway. Okay. So API gateway as a trigger means that when you call the API gateway, that will call the Lambda. Okay. So I'm going to select API gateway. Create a new API endpoint. Yes, I want to create a new API endpoint, and the new endpoint is going to be called user info. So I'm going to create a REST API. Okay. Security, I don't care. I'm going to say it open. Open means anybody can call it. But if I do care about security, who can call it and all that, I'm going to select IAM permissions and all that. There's also API key. That means you can have your own keys associated. You can validate your own keys. So as I said, you can have mix and match. Mix and match means your security is taken care by data center in-house users. You can have a key. You can send the key and all that. But in this case, I'm just going to leave it as open. Okay, that means anybody can call it. Yeah, that's it, fine. So I'm going to add this. Okay, so this actually created an API gateway endpoint also. Okay, so this is a shortcut that I was talking. So when I create a Lambda, I'm actually creating a gateway endpoint along with it. And yeah, so what I have here I have a Lambda and I have an API endpoint. And you can see here, it also gives me this API endpoint. Okay, so you can see, let me copy this, just a link. Okay. I copied just the link. Okay. Now imagine, now if I go to that link, that will give me that will call this Lambda, which was executing. and then it will give me that hello from Miracle Solutions. So let's test it out. Okay, so I'm going to go to my local machine. Okay, I'm going to open up Python command line. Okay, hopefully you guys can see the font, but if not, I'm going to increase it a little bit. I'm going to say import the requests. Okay, so using the request library, I can make a request. Okay, so I'm going to say request.get URL equal to. So this URL is what I copied from there. Okay, I'm going to call that. So I got 200 status point. Okay, I'm going to put it in a response. Okay, I got a response now. Okay, now if I print response.text, guess what? I'm going to get hello from Miracle Solutions. So let's see. Now what I'm doing here is I created a Lambda on the AWS platform, and I went to my local machine, and I'm calling that API endpoint. Okay, so this is the API endpoint, which is here right here. Okay, so I call this API endpoint, and this API endpoint called the Lambda. The Lambda executed some piece of code, some piece of Python code and everything, and it returned a response. And guess what? I got that response from here. Okay, so that is a simple Lambda, but you can even add more functionality in the Lambda. Okay, so let's say let me open that Lambda one more time. Code. Okay, here it is. Okay, so if we go to the code, and then let's say I want to connect to relational data store. Okay, so there's a database. I want to connect to the database. I can do import boto3. Boto3 is a library, so I can do boto3.connect. Okay, hold on one second. Let me look at audience. So boto3 is a library that's provided by AWS Framework. And this is something that you can use to connect to different other AWS products and all that. Okay. So here I'm going to go here, and let's look at a simple example of how to connect to a relational data store using the boto3 library. I'm going to take this code, I'm going to put in the Lambda. Yeah. I'm trying to find a simple example here. Okay, boto3.client. Okay, RDS data. Okay, fine. Okay, so I guess you need to have the database name here. Let's see. Yeah, I guess, okay, so that's what you need to do. Okay, so here I created a database called as demo database before. Okay, so I'm going to do demo DB. Okay. And this is very similar to what we did by using Python, connecting to database. We provided a username password as a connection parameters. We got a cursor. Using a cursor, we did a execute select statement, and then we loop through the results, we print the results and all that, right? So here it's very similar. So we use a boto3, we connect to the database. So we get a connection object. Okay. So once I get a connection object, I can execute statement. Okay. So here it specifies what kind of statement you want. SQL is pretty much here. Select star form and all that. Okay. So here it's actually inserting into the table. But in your case, it can be select statement or anything. And then you execute that statement here, which is, okay, here we go. So there's another example here. Yeah, execute statement. Execute statement is going to execute that select statement. And then you're going to get a response, which is pretty much a bunch of records back. You're going to loop through the results, okay, which is the same as what we saw last time. Okay, that means we're connecting in a different way, but you're still connecting to the database. You're executing a statement, you are getting a cursor, you are looping through the results. Same thing here also. Okay, so there's no difference here. So pretty much I would do the same thing inside a Lambda. So the Lambda can be as complicated or as simple as you want. You can do whatever you want to do inside the Lambda. And when I call this particular endpoint, okay, when I call this API endpoint and so on, that will start executing whatever you put inside the Lambda. And then it will get a response. Whatever you say inside the return, that will be returned as a response. Okay. But yeah, so that is how one of the use case of Lambda. I mean, there are 10 different options that you can use a Lambda, but API gateway is one of the options that you are exposing some endpoint using the gateway, and then you are hooking up to Lambda. That means Lambda will be executing the code, it will be returning a response and all that. Okay. You see another option here, layers. For Python, you may not need much layers, but let's say you want to load something else. Let's say you have a Java program. Okay, when you have a Java program, you have to load some libraries or a C++ application. You need certain libraries to be loaded before your Java program can run. Okay, so all those kind of setup goes into layers. A layer is pretty much where I'm going to add a layer here. For Python also there can be some layers. Let's see. No compatible layers. Custom layers specify an ARN. Yeah, Python. I don't. Let's see. Let's SciPy. Is there anything for SciPy? Scikit library. Okay, fine. For Python, it doesn't make much sense for the layers. But let's say you have a Java application or C++ application. You want to load some libraries. The layers comes into picture, so you can add a layer. That means it will load the library, and then you can start using that library inside the Lambda. Okay, so you have to specify what is that library before you start to use that library. That is where the layers come into picture. Layers is pretty much some dependency software that has to be loaded before the Lambda has to execute. Okay. All right, so I'm going back to AWS Lambda one more time. Okay. I have a user info that I just created. Let's go to test actually. Yeah. Succeeded. Okay. All right. So yeah. So I created a dummy test data. Okay. And then I said press the test button, and that actually ran the data, and that gave me a response and all that. Okay, so this is the response that I got back. So this is a test case. So you can test it from the UI option also. But yeah, so let me create a new test case, or let's change the code here a little bit, which says print the event and all that. Okay, so I'm gonna go to code. Lambda function. Okay, so I'm gonna print the event, print the context. Okay, so I'm printing what is the request, which is an event. Context, let's see what is the context has. It should have what is the user, what is the tracking ID, and all those kind of stuff. But let's save it and deploy it. Okay. Sorry, I should have pressed test. Okay, I'm gonna test it for a second. Let's go to the test module here, and let's press the test button. Okay, so it says failed. Why is it failed? So before we go into white failed, you can see that it says build duration 2 milliseconds. Okay, I gave a credit card when I created that account, a free account, but still I'm getting billed here every time I press a button because it's keeping track of how much usage I'm using the system, and based on that, it's going to bill me. Okay, so this is the standard way of how AWS works. In the sense, if you consume more, it's going to be billed more. But yeah, it also tells you where are you using it, what are you using these resources for, memory used, duration, and that. Okay, so the total duration will be, I guess, I'm not sure whether they're going to bill for this duration or 2 milliseconds. Maybe I'm guessing 2 milliseconds. Yeah, okay, fine. So let's see why it failed. Okay, so let's click on the logs. Okay, log is pretty much where we're going to see all the events, everything that happened with it. Okay, now you can see that it's taking me to a product called as CloudWatch. Okay, CloudWatch is pretty much a logging mechanism. That means I can see any error, anything that happened with CloudWatch. I can go to CloudWatch and I can see what happened there. Okay, so let me click on. Okay, it is giving me user info log, but I don't see any log here. There has to be some log here that specifies what happened there. Um, okay. So anything PostgreSQL that I created some time back is giving me all the events that happened there. But I'm looking for user info log. Okay, fine. Let's go back here for one more second and click on the logs. It looks like I have to create a log group called as user info log group. Okay. Looks like it's unable to pull. Maybe there is some setup that is incorrect. But when I click on this logs link, it has to take me to CloudWatch, and it has to show what is the output. Because I did say print this, print that. Okay, print which is the request. If I go to Lambda function, so I said print the event, print the context. But yeah, it should have printed those to the log files, and I was expecting to go to the log and look at it, but for some reason it's unable to send it to the logs. But yeah, so this is a Lambda that is exposed. You guys can try it too, actually. So you can create an endpoint, and you can go to your local computer. You can request for some data. But let me give you this sample thing. Actually, this is pretty basic. It's already there. So that's since we are looking at CloudWatch, I also wanna let's talk a little bit about CloudWatch. Okay, so let's say you have some services that are running on Lambda, some services that are running on Elastic Compute, something running in the database. In the sense, people are connecting to database and all that. Okay, and now you have errors happening. That means there is some error that is happening somewhere, but it's running in the cloud. That means it's running on AWS platform. You don't even know that some error happened until some client comes to you and says, hey, I'm not getting this data, and you want to take a look at everything, and so on. Okay, but that means By the time the client notices the issue, it's already too late. That means they know that the software is not working as expected. So you want to catch the errors as soon as they happen. That means when the software doesn't work as expected, you want to go to that CloudWatch and try to see why the error happened, what is the error that happened, and all that. So the CloudWatch helps you to look at those different logs and so on. Okay. Now let's say there is a error that happened. You want to be notified. That means you want to get an email alert or phone alert and so on. Okay. So on the left side you see there's alarms. Okay. I'm going to click on alarms, and this can hook up to something called a simple notification service. Okay. So I'm going to go to simple notification service for a second. There we go, the simple notification service. So simple notification service is an email alerts. You can do simple things like email, mobile text messages, kind of stuff and so on. So here I'm going to create an email alert. Okay, so on the left side you see there's a text messaging. There should be email alerts. Let's see. Yeah, you see application to person. Okay, application to person means you are sending an emails kind of stuff, and you can see here there's an email option, text message, push notifications, and all that. Okay, so I'm going to click on learn more. Email notifications. Okay, so sign to Amazon SNS console. Choose subscriptions. Okay, so let's see on the Okay, I'm going to go to subscriptions. I'm going to create a new user or so on. Okay, fine. For now, I'm gonna let's see, protocol, simple notification service, email. Okay, yeah, topic. AWS stands for Amazon Resource, all that. Okay, that's fine. Okay, so I'm going to create an endpoint for saying so contracted Miracle Solutions, subscription filter policy. So if I create this subscription, it's asking for available topic. Okay, yeah, I guess this is more of like queuing service. Okay, so what happens is this, right? So whenever there's an error, this can send a notification to the simple notification service, and the simple notification service can send an email alert and all that. Okay, so it makes it a little easier in the sense you don't have to worry about having an email server that is running, or some way to send a text message out and all that. So that is already provided to you. So you just use those services to send a text message, to send email alerts and all that. So that's already provided to you, kind of stuff. Okay? I have to just verify. Yeah, topic is pretty much the topic. Here in this case, the topic is going to be user info. User info is failing. So that's a topic. So I have to create a topic for that. But yeah, for now, let's ignore. But yeah, CloudWatch is pretty much, which is kind of like watching databases, applications for different kind of errors. And then it can notify you saying that some error happened. Go take a look because before the client notices, you want to fix the issue and all that. Okay. So that is what the CloudWatch stands for. All right. Any questions so far? Okay. Yes, sir. Go on. Yes, Smita.
Okay. So all these resources like creating the database and giving the IAM role, all these things will be taken care by some DevOps team, or as a developer we need to involve in all these things.
Yeah, as a developer, you might be involved. I mean, It depends on the team structure also. Um, but you might, even though DevOps team is creating the roles, permissions for you, you might have to tell them that you want to access the database. You want to, maybe specify what are the different permissions, like read permissions, write permissions, kind of stuff. So if it's a small team, small company, maybe you might be doing it, or there may be a DevOps team that takes care of it. In some cases, it might be DevOps because you can have a Terraform template, and the templates are pretty much what those guys, DevOps teams takes care of. But I speak with some DevOps people, and they say developers take care of it too. But yeah, it can be either way. Yeah.
Okay. And coming to RDS and Redshift, may I know the major difference?
Yeah, sure, definitely. Yeah, we can talk about this. Yes.
Okay.
Yeah, so before I go there, so we looked at Lambda, API Gateway, how to connect API Gateway to Lambda, and then we made a request to API Gateway, which called Lambda, and then returned a response. Okay. Now S3. So let me go to S3 real quick, and then we'll come back to RDS versus the other one. Okay. So S3 is here. So I'm going to S3, which is storage system. Okay. Now S3 has a concept of bucket. A bucket is nothing but a folder. Okay. Think of it like a folder that is grouping other folders, or it can group certain files. So all the group is called a folder on your local system. But same thing on AWS platform, you'll be calling that a bucket. Okay. So I'm going to create a bucket here. I can name the bucket whatever that I want. Okay. So again, the data, you want to expose it to the internet. You don't want to expose it to internet. You want to set some permissions. So here you can see versioning. Okay. So what the versioning means is that let's say you have a file and you overwrite that file. That means, let's say you modified some data and you overwrite that file. You still want to have an old backup of the file. That is where the versioning is. Okay. So when you enable the versioning, that means you should be able to access the previous version of the file, all that. Okay. But if you enable the versioning, now you can imagine that every time you change the file, you are actually creating a new version of the file. So you're going to consume a lot of space. That means your billing is going to be higher and all that. Okay. So for now, I'm going to select disable. But if you do want to store the old file, then you can enable it, enable the versioning. And okay, so once I create this bucket, okay, so let me create this bucket here. Must not contain uppercase, okay. Oh, we're going to send them already exists, okay. Okay. Archive bucket or something like that. Bucket with same name already exists. What? I think there's archive bucket. Okay, let me just name it with some numbers. Okay. All right, so I created a bucket here. Okay. Now, if I go to the bucket, I can upload some files, or I can create another folder, all that kind of stuff. Okay. So that is what a bucket is. Now, there are permissions for the bucket. That means who can do what. Okay. And access control list. Okay. So you have what kind of access do you want? Do you want everyone public access? Do you want authenticated users or so on? So you can select what kind of users can access. Okay, and there's also ownership. That means we saw before what kind of user groups, what are the permissions they own, and so on. So this is where the ownership comes. Who can modify the buckets? Who can modify the files and all that? But yeah, so let's. That is what the bucket is. S3 bucket is. You set the permissions on the bucket. You don't set the permissions on each file. So yeah, and then you have access points. Okay, so that means you want to access this over the network. Okay, that means you want to somehow use this bucket, put a file on the bucket, get the file, and so on using an API. Okay, so that is where the access point comes into picture, and you can create an access point, and using this, you will be able to access the data, access the files inside the bucket, or upload the files and all that. Okay. Yeah. So that is S3. Now let's look at what's the difference between relational data store and what is the other one you said, Smita? DynamoDB or
Redshift.
Or Redshift? Okay, fine. Yeah. Right. So let's go to Redshift. So RDS, relational data store, as we saw, is pretty much a relational database. It can be a PostgreSQL, MySQL, and everything. Okay. So if I have a bunch of tables and there's a relationship between the tables, perfect. That is good enough for me. Okay. Now, the RDS relational data store may not be good enough for a huge volume of data. Okay. Let's say you are storing data from every team in your company into a single database. Okay. That means so let's take two use cases. Okay, let's say I have some data in RDS, relational data store, under PostgreSQL. Okay, so PostgreSQL has user table. Let's take the DVD rental database. Okay, so you have a DVD rental database, which is you have the customer information, store information, sales information, address information, all that. Okay, so that is only one database. Okay, now if you go let's say you have, as a company, you might have different teams working on different products. Okay, you might have 10 different databases storing different data in each of the databases. Okay, similar to DVD rental, there is something else in the company, user information, or maybe some other product and everything. Okay, so all that information is in a different database. Okay, so you have like 10 different databases, and you want to store all those into a single database, kind of like an ETL kind of a pipeline. Okay, so now you are bringing a huge volume of data, and you are storing that huge volume of data every day. Okay, that means that you are getting some files from different teams, and you are extracting those files and loading them into the database. And this data is not going to be small data, because every day you are inserting maybe hundreds of millions of rows and everything. Okay, so for that kind of a performance, for that kind of a database scenario, relational data store is not a good choice. You may want to go with the Redshift. Okay, Redshift. Okay, so this gives you more of like ETL kind of a pipeline. So you can. So most of this data is store it once and access it multiple times, kind of stuff. But the application data, like DVD rental, you're modifying the data on the fly, kind of stuff. But this is ETL data. That means you're getting the data, you are storing them, and so on. So you can think of this like a data warehouse or a data lake or ETL pipeline processing and all that. So this is huge volume of data, but at the same time, it's going to be cheaper and all that. So that is where the Redshift comes into picture. So for any ETL pipeline, you might end up using Redshift, or you might end up using maybe DynamoDB. But ETL is the best. Redshift is the best for ETL kind of use cases. Okay. Yeah. Okay. So I've been talking a lot, and I see some of the team members are missing here. Probably because I didn't notify them today that this session is going to be here. So I want to kind of like give a stop here, and then maybe in the next session, if you guys want more, I'll have another session on AWS platform, and then we're going to have more practical things. So here we have a simple demo of that particular Lambda, going to Lambda, getting that. But in the next session, we're going to look at maybe SQS, queuing service, maybe event bridge. That means you have a scheduler at, let's say, 6 p.m. You want to run some job, so you can schedule certain things on AWS platform at 6 p.m. or whatever time you set. It's going to execute the Lambda. So in our case, I'm calling the API gateway. Gateway is calling the Lambda. That is one use case. Okay. Now you can also use Lambda to put on a scheduler. That means when the time hits, it will execute that function. Okay. Or you can also say S3 bucket. Whenever I create a new file on S3, can you please execute the Lambda? Okay. So the Lambda can also be executed when you modify a file on S3, upload a file on S3 bucket, and all that. Okay. You can also run the Lambda when there's a publish subscribe kind of a mechanism. That means one of your team inside the company, let's say somebody created a user somewhere else. Okay, they create the user, and you are keeping track of, let's say, generating a report. How much profit this user generate for us, or so on. Whatever you have a separate process. So somebody else has a separate process. They are creating a user. You have a separate process that does something else. So you want to be notified with a message saying that some user got created. Okay. So here the notification comes in not from outside the world, from other user or from other client, but it's within the another Lambda can start this Lambda also. Okay. So one Lambda can notify the other Lambda. Or you can also have one Lambda publish a message. That message goes to queuing service, simple queuing service, and that another Lambda reads that particular message and all that. Okay, so there are many ways you can start the Lambda. So we're going to look at those things maybe in the next session. Other than Lambda, I'm also going to talk about maybe there's a glue jobs, which is Spark applications. So let's also spend maybe like a little bit of time because Spark, I haven't talked about Spark applications in our regular sessions. But yeah, so I might talk about Spark also. I will try to see if I can simplify it to a simple 5 lines of example. I'll probably use it. But if I have to put like 20-30 lines of code, I might skip it for later sessions. But yeah, so those are the things maybe I'll talk in the next session. Fine. Yeah. There's nothing for me. Okay. Another thing. Yeah. So let's. So we are using Management Console here. Okay. So this console is what I was using all the time. Clicking, creating this, creating that. But this is not how you would do it. I mean, if it's a simple demo kind of stuff or testing kind of stuff, you would use a console. But if it's a real world, you may have 20 lambdas or 50 lambdas or 500 lambdas, who knows. Manually creating those lambdas is not feasible. Feasible means you're not going to be able to do that. If you do that, then you will be dedicated just for uploading that lambda or creating modifying the lambdas and so on. So most of the times we don't use the console. There is something called as Terraform templates. Okay, so if I open up some example of Terraform template, okay. So here I opened up a Lambda Terraform template, but it's pretty much what Terraform template means is that any resource on AWS platform, I can let me just click on this one. Oh, here it is. Okay. For this, let me go back to. Okay, fine. Okay, fine. Yeah. So Terraform is a template mechanism. That means I don't need to go to console, but I can actually create some code that when I run some commands, it's automatically going to create there. Okay, so let's say I have some file. Forget about the right side part, this part, where it's a Terraform specific tags and all that. So let's not worry about that. But you can do something like this. Okay, you say Terraform init. That means that will do some initialization, and then Terraform plan and apply. Okay, so the apply, what the Terraform apply will do is it will apply that file to the AWS platform. Okay, that means if you write some code there saying, I want this for the Lambda, and you say Terraform init and apply, that means that is going to create that particular Lambda on AWS platform. And it will look something similar to this. Okay, you're going to say module, what is the name of the Lambda? I mean, this is a very simple example here. But you're going to specify what is the source code. The source code can be, in a sense, it can be a file that is sitting on your S3 bucket. So in this case, it looks like it's some file location, directory, and all that. So it's pulling from there. And then he has a version. Remember, S3 also has a versioning mechanism and so on. That particular version and all that. So you can use that S3 versioning. So all the things that we saw from Management Console, that you can create a layer, Lambda layer, you can create API keys, permissions, IAM role, where is that role name, what is the role name and all that. So these are the IAM role permissions. Anything that we saw in the Management Console that you're clicking and everything, you can actually specify it as a tag key value pair. As you can see here on the right side example, this is a very simple example. But yeah, so you have something like left side is a tag, what is a tag, and the right side is a value, key value pairs. And then when you do Terraform apply, that will pretty much create the resource on the AWS platform. Okay. So we're going to look at Terraform templates in the next session, and we'll create one of the resource using the Terraform template. Okay. So for that, maybe we have to, I mean, I'll send you the instructions how to apply or install Terraform. But this is purely for developers. This is not for testers. Okay. So if you're a tester, you can even skip the session. Or if you want to join the session, that's fine too. But yeah, this is more geared towards developers. Okay. But yeah, so this is one way you can use Terraform, okay, to create the resources. The other way is a Boto3 library, okay. So as you were looking at before, Boto3, let's say I want to create a S3 bucket, okay. So we use the Management Console to create the S3 bucket. You can also use this Boto3, which is a Python library. Okay, so you can write some Python code to create the S3 buckets and everything. Okay, so you can do something like this: import Boto3 client equal to this particular S3 client, and then you can say create bucket. There's an option. There's a function for creating a bucket. So programmatically, if you want to do using Python, you want to create a bucket. Then in those kind of cases, Boto3 would be the use case. Okay. There's another way. You can also create resources, which is the AWS command line interface. Okay, so if I go to my command line interface, I already have AWS command line interface. Okay, so here, if I do AWS S3 minus H minus help, okay, fine. So here you can see there's a AWS command line interface also, and I just did S3, but you can also specify other resources. Okay, so I can also say AWS Relational Data Store. Yeah, fine. I think there is another, okay, let's see, AWS minus myself. So you can use the command line interface to access the AWS resources, and you can create the resources, you can delete the resources, all using command line interface if you want to. Or you can also use programmatically using a Boto3 library, using something like import Boto3, create bucket, all those stuff. So that is also second option, which is a Boto3 library option. The third option is the Terraform templates. Terraform is the most preferred way, and I'll tell you why. But Terraform is the most preferred way. And then, I'll tell you why in the next sessions, because that needs some explanation. The final option is going to Management Console. So let's say you want to go here, you want to click on a button, you want to create the resource and all that. So that is one other option. Okay, so you have 4 options totally. How to create resources, manage resources, and everything. Okay. Yeah, hopefully this session was useful, but in the next session it will be even better. Then we'll see exactly how to create these resources using better options. Yeah, but I would say this is where I would stop. And yeah, if you have any questions, then let's take them. Yeah. All right, guys. So if no questions, then probably I'll stop here. And there's nothing for me to give you an assignment or anything like this, because pretty much, yeah, whatever I demoed is a very simple, high-level explanation kind of stuff. But yeah, there are many products of AWS. And as a bottom line, I want to say that long time back, like at least like 5 years back, 7 years back, if you want to start a company, you have to have a data center, you need to do this, do that. It was a big deal to start a company. But right now, if you have an idea, you can go to AWS, you can create some resources, and you can write the software, and you can pretty much bring up your company in like no time, because all the infrastructure is provided to you, and that helps it much faster. That means they are not setting up a data center, it's already provided to them. So right now, if you can write some good piece of software, if you have a good idea, I think, that is pretty much all you need, because the software infrastructure already is provided by these guys, AWS, Google Cloud Platform, and all that. All you need to do is implement that idea, and that should be pretty, if it is good, that's going to be pretty successful. Okay? Yeah, but that's how the dynamics are changing. And I see a lot of companies are moving to AWS. Azure also pretty much a lot of, Azure is also picking up market share. But yeah, these are very useful products. All right, guys. All right, so I'm going to stop here. And if you guys have any questions later on, you can send me on WhatsApp or text message, and we can talk. Okay, all right, guys. Enjoy your weekend. We'll talk later.
Yeah. Right. Thanks for today's session, Vasu. Looking for next one.
Yeah, sure, definitely. Yeah. All right, guys. Bye.
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 Thank you, Ravi. Bye.